How are you guys? Welcome back to my YouTube channel. In this video we're going to discuss about the chain rule. This is a mathematics and 5. We're going to see what is the chain rule. It's a function of function. Let's say we are given uh, a function of function. What I'm trying to say, it's a function inside of another function. Like chain rule, if you have given y is equals to uh, f of f of g of x, like this. We have the function inside another function. Right, when we differentiate this, if you differentiate this dy over dx, we are going to take the derivative, going to differentiate what is in the outside, g of x, like this, g of like that, and multiply by the derivative of the inside function, which is g of x prime, like this. We call this chain rule. For an example, let's say we are given f of x to be equals to x raised to the power of 5, and we are given again, and g of x is equals to minus 3x plus 1. So we're using that, as you can see, taking this finding. Now I want us to find the f of g of x, like this. What I'm trying to say, I'm meaning, now you see this, you take this, the functions, you put it inside of this function there, and then what is this function we have given to be equals to that, right? That means here where we see x, will replace with that. All right, this is still an int, right? So we'll have f of x, I will replace the x with minus 3x plus 1. Here we have what, raised to the power of 5. All right, guys, are we still together? So we've seen them, what we've seen, that we were supposed to we've seen how we differentiate that, right? We differentiate of prime using this rule there. We differentiate f of prime. Now you take the derivative of the f of prime. F of prime is the whole this. If you differentiate, you differentiate that, the f of prime, then you release that. So this is actually, in actual fact, this is the same as in actual fact, this is it's equal to negative 3x plus 1 raised to the power of 5, is like that. So if we want to differentiate that, check, we differentiate f of prime is what, you will differentiate the f of prime. F of prime is the whole of this, is the whole of that, it's the whole of that. We'll use what, the power rule. Remember, you have the exponent, you'll drop the exponent, which is 5, then you multiply by what, you'll write this as it is, minus 3x plus 1, then you minus 1 down the exponent, you left it 4, then you multiply by what, you multiply by the derivative of the inside function there. As you can see, the derivative of the inside, what is the inside here, is negative 3x plus 1. Derivative of negative 3x will be minus 3, then plus the negative plus the derivative of 1 is simply equals to 0. All right, so this will be simply equals to the negative 15. 5 multiplied by 3 is into 3x plus 1 over 4. So this is how you find the derivative. So far, as you have seen, guys, it doesn't necessarily that we have to do all of these substitution and substitution. So will be given us in this manner. They will be given onto us. They will give us as a function of function. What I'm trying to say, meaning you in your exam, or if you are dealing with your classworks there, you will be given already as a function of a function. What I'm trying to say, as a function of a function, will be given this already. Let's say find the derivative of the following. Let me say number one, you'll be given this as a function of a function. They've already replaced this inside for you. You won't be given two separate functions. You won't be given two separate functions, but you'll be given a function of a function like this. Let's say you're given this. They've already did it for you. That steps. It is no longer you have to substitute. So we have given these guys. So we have to find dy over dx. Now, what did I said? We differentiate the whole of this. Remember, you apply the power rule, you drop the exponent. This is the same as, like, guys, if you have x raised to the power of 3 will be right. Will be what? If you take the derivative of this, you're going to drop the exponent, right? If you drop the exponent, you're going to have what? 3. Then you subtract the exponent, will be x raised to the power of 2. This is one and the same thing. Use the power rule. It's just that we have inserted, remember this is a function, is x. Doesn't mean it will always be x. It can be a function here multiplied by the derivative of x. The derivative of x is simply just 1. So that is why it does not affect anything there. So we come here, we come here. So we drop the exponents there, multiply by the exponent which is 3. Then obviously we write this as it is, 3x minus square root of 3 of x plus x squared, like that. You draw minus the exponent, you'll have 2. Now you multiply by the derivative of this inside. The derivative of the inside. Derivative of the inside, you'll multiply by the derivative of 3x is what? Is 3. Then minus, we have a minus there. We have that root, the square root of x is the same as x raised to the power of 1. Then you multiply this by 1 over 2. Then you subtract this, you subtract the exponents. There will be negative 1 over 2. There you will have negative 1 over 2. Let me erase here. You'll have negative 1 over 2. Remember, the square root of x is the same as what? Can rewrite this to be 1 over 2. You drop the exponents there, we'll have 1 over 2. Subtract 1, be negative 1 over 2. That is how, what I've did there. So that is what you'll have there, guys. That is what you'll have there. And by the way, that is what you'll have. Then plus, again we have plus here, multiply by the derivative of that will be 2x. You subtract the exponents. So this is typically what? The chain rule. Remember, there's no need for simplification. Most of the time in your exam, there's no need for simplification. They just said differentiate. So even if you have not simplified, there's nothing wrong there. Even if you have not simplified, I have multiplied by 3 is the same as negative 1 multiplied by negative 1, 2x square root of that plus 2. But anyway, there's no need for simplification. You can end here. That is how it go about. Let's say number 2, you've given y, it's equals to minus 2e raised to the power of sine x. They say differentiate, find dy. They say find dy over dx of this. if you find that, you know this is an exponential. How do you differentiate an exponent? We know this even from N4 level. We know how to differentiate this. Will be dropped, will multiply by the derivative of an exponent, right? We'll multiply by the derivative of the exponents, whereby what is our exponent is sine. The derivative of sine there, here we have 2 in our coefficient. We'll have minus, here we have -2, right? Now we have -2 multiply by the derivative of our exponent. When you differentiate sine, we'll have what? Positive cos x. Then you rewrite this as it is, obviously. Will be what? E raised to the power of what? Of sine x. You rewrite that as it is. You don't change anything. You write that as it is. Sine x like that. Multiply. It's supposed to be multiplied by ln. You take the base, which is e. But now, there is no need because ln e is the same as 1. Remember, ln e, there's a default base here, which is e. We don't write this e here. This is the same as 1. So even if you did not write that, even if you don't write that, this will just simply equals to what? To 1. So this is just a simplification. Yeah, you just differentiate. Most on your question, they will say there is no need for simplification. They are not required most of the time. So you have just to differentiate like this. Then we are done them. So let's say now again we are given to differentiate. Let's say number 3, y is equals to minus 2 sec squared into 1 minus minus 3 x raised to the power of 2, like this. Supposed to differentiate this dy over dx of this simply equals to what? All right, we have minus 2. Minus 2 is just a constant. So you're supposed to differentiate sec squared. Sec squared, guys, this is sec squared, guys. Remember, now we're dealing with what here? We must not forget, now we're dealing with what there. See, this is the sec squared. You see? So we had this raised to the power of 2. So you must use the power rule. Power rule, you drop the exponents, you'll multiply that by 2. Then do not forget, you rewrite this as it is. It's a power rule, right? We'll have sec minus 1 there. It will be sec 1 minus 3x squared, like this. Then multiply by the derivative of the inside using the sorry, before you come to that, you multiply by the, remember it was a power rule, you multiply by the derivative of sine of sec squared. What is the derivative of sec not sec squared, the derivative of sec? Actually, after you drop the exponents, you forget about that part. As you have dropped the exponents, you come again, you multiply by the derivative of sec. What is the derivative of sec? We'll simply multiply by what? By sec tan x. Remember, it's sec tan. So this will be sec. You write all of these. 1 minus 3x squared, by the way. Multiply, remember this is a multiply by tan. We have that tan. Let me do like this. Let me make a space here. All right, multiply by tan what? The same angle, remember guys, 1 minus 3x raised to the power of 2. Why? Remember guys, when you're if you differentiate, if you take the derivative of sec squared like this, x, remember this is equals to sec x multiplied by tan x. So the angle, you write this angle as it is, the argument, we call it that angle there, you maintain it. So is what you have there. We have used that, then we have maintained that, isn't it? But now we are not done. You did this, you differentiated this, then you come to the inside. Now you differentiate the inside, you multiply that by the derivative of 1. It's what? The derivative of 1 is simply just here, relieve that, you multiply by the derivative of what? Of derivative of minus 3, you differentiate minus 3 right there, isn't it? Differentiate here, minus 3x squared, you're supposed to drop what to the exponents, you'll drop the exponents there, will be 6 negative 6 x negative 6 what x. So will be this will be simply equals to multiply by this by negative 6 x, like that. So all right, this is what you have there. So this will be equals to 4 multiplied by this, there will be positive 24, we have that x there, positive 24x, then this and this is the same, check, this and this is the same, isn't it? If we multiply, this will be simply equals to what? Sec squared 1 minus 3x squared. Remember, this thing is the same as x multiplied by x will be x squared. So those things are the same. Multiply by our tan minus 1, 3x raised to the power of 2, like this. This is what we have there. That is what we have so far. This is how you go about dealing with our simplifying our chain rule. That is what you are supposed, you have to do. This is what you have to do, guys, there. All right, let's say again, you have given I can say there, let's say I've given y we say I've given y again to be equals to x multiplied by ln minus 1 minus 2 cos x, like this. All right, so then we want to find dy over dx. So here we have x and also have x. These are products, guys, so we have to apply what? Product rule. We must apply product rule. What does product rule says? Remember, product rule, if you have given dy dx of this function f of x multiplied by g of x, it simply equals to f of prime x multiplied by g of x plus f of x multiplied by g of x prime. So you multiply that, I can make x, I can say x will be f of prime, ln of that will be g of x. So if we take dy over dx of this using our product rule, we take the derivative of the first. Derivative of x is what? It's 1 multiplied by f of x by g of x, which whereby will be ln 1 minus 2 there 2 over 2 cos x, like that. Then we have plus now the f of x is what I said, it's x, will be what? X multiplied by g of x prime. We differentiate this now. When you're differentiating ln, you must be very careful. Multiply by what? Remember the derivative of ln. Let me just write here for recap. When you differentiate ln, for an example, ln x, if you differentiate ln x, you take the derivative, or let me just write it like this. Maybe let me say ln, or let me say f of x like this. If you differentiate ln like this, oh, let me not put, oh, let me not show, let me not say f of prime. Let me not say f of prime. Let me say f of x like this. You'll say you'll multiply the numerator by f of prime x, then you divide by f of x. You see, you divide by this original, what is inside here. You take the prime, you differentiate it, then you divide by that. For an example, let us make an example. Let's say we have ln 2x. Following this, if you differentiate this will be equals to what? If you take the derivative of this will simply equals to what? The f of x prime there will be what? You differentiate what is inside, will be what? 2. Then you divide by the f of x, which by is what? Is 2x. Then this and this will cancel. It's 1 over x, like this one. So you see what is going on there. So we're applying this there, that rule there. We're using this rule even here, guys. So there we have ln, our f of x will be the whole of that. Will differentiate 1, derivative of 1 is 0, minus derivative of 2 cos. Derivative of cos is what? Is positive. Is positive, what is negative sign. So negative times negative, this will become positive sine x. Remember, when you differentiate, cos will be negative, but already we have a negative. The negative with negative will be positive. Then you divide this, supposed to divide this by the original, that by 1 minus 2 cos x, right? This is how you differentiate. This is how you are differentiating. This is how you are differentiating. All right. This is how we differentiate. So these guys is simply cos 1 multiplied by this will be ln 1 minus 2 cos x. All right. Plus multiply there. This will be x sine, or this is x sine minus 1 2 cos x. So this is what you will have here, guys. That is how you go about differentiating these typical questions. Let's say I've given this typical question again. Let's say we have let me say we've given y to be equals to be sine raised to the power of 6 into ln 4x raised to the power of what of 5 like this. Then you should differentiate this typical. How can you go about and differentiate this typical question? You have to find dy over dx of this. Alright, you multiply, use the product rule, or use the power rule, not product, power rule. You multiply by the exponents is 6. Then you'll have sine, you subtract 1 there on the exponents, will be what, 5. There, still have ln 4x raised to the power of 5, like that. Alright, remember now, then you did that, and then you come now, you differentiate sine. What is the derivative of what? Of sine. Now you multiply by the derivative of what? Of sine. Sine will be cos. Then we have cos, we'll have cos ln of 4x raised to the power of 5, like this, right? Come again, you multiply. Actually, you take this direction, you go that direction, you'll differentiate, you'll multiply by the derivative of that. We come again, you multiply by the derivative of the ln. You are still multiplying. I've run out of space, I will multiply, but remember we're still multiplying there. I will just let me reduce this. Maybe it's reducible. Let me reduce this. Alright, if I reduce this, multiply, as I've said, by the derivative of ln. Derivative of ln, we know that will differentiate what we have there, will be 4 multiplied by 5 multiplied by 4. Here we'll have 20 x, subtract 1 raised to the power of 4, all over the original, that will be 4x raised to the power of what? Of 5. You are done with that. You come now, you differentiate what is there, the inside again. You multiply that by what? You drop the exponents again, will be 20x raised to the power of what is this? 4. This is what we have here. This is what we have. This is how you go about differentiating this or applying the chain rule. Alright, there's no simplification here, they are not needed for now. Alright, this is how you go about. Let's check here. We have, let's say, given x to the power of let me check, to the power of what? Let me say x to the power of 2 plus 4 all over x raised to the power of 3 minus 3x plus 6 raised to the power, all this raised to the power of what? Of 4, plus the square root of 2x minus 5. Then we're supposed to find this is y. I can call this y. Let me say this is simply y. Can call that y. Y will be equals to this. So this is y. So if I take dy over dx of that, what is going to happen there? You drop the exponents, we'll have 4. Simply just drop the exponents. There we'll have 4, isn't it? 4 of x squared plus 4 over x3 minus 3x plus 6. You minus the exponents, there will be raised to the power of 3. Now you come to this guy. Remember that it's a that guy is the same. Remember this 2x minus 5 is the same as 2x minus 5 raised to the power of half raised to the exponents of half. So we know supposed to drop the exponents there will be 1 over 2. Then subtract the exponents there. We'll subtract the okay, before we go that, sorry, by the way, before we go that, yeah, I think I'm tired. I'm doing such a silly mistake. The rule supposed to apply our chain rule again. We multiply by the product of the inside. I think I'm tired. Sorry about that, guys. Multiply by the that, but now this it's a fraction, guys. We have x, that means we have to apply a quotient rule. Quotient rule states that if you have if you differentiate, for an example d, let's say you want to differentiate f of x like this over g of x, state this will supposed to be equals to will be g of x multiplied by prime of x minus f of x multiplied by g of x. All this you square this g of x over what squared. So this is what we're supposed to follow there. The top I will call it will be the numerator. I'll call it will be like f of x, the g of x. So if you do that following this format, our numerator is this one, g of x. There will be x squared minus 3x plus 6. Right, now we differentiate we differentiate the top part. We differentiate that. If we differentiate x, we drop the exponents there. We drop the exponents. Remember, now we have to multiply this. We have 3 terms here. As we are multiplying, let me just put some brackets like this. I will multiply this by what now? By will be differentiate x squared will be 2x, then the derivative plus 0, just a constant. 4 will be 0, so there's no problem there. Then we subtract. Now we come this side, multiply by f of x, which is will be x squared plus 4, then multiply by the derivative of this. Then remember, we'll drop the exponents, will be 3. Let me that is what we'll have there. Multiply by multiply this by, okay, let me make a space a little bit. Let me make a space a little bit there. Let me reduce this a little bit for the space. Alright, we'll multiply this. We're still there. Multiply this by the derivative of this whole that. Now will be drop the exponents, will be 3x squared minus 3x. Alright, this is what we have. all over this. We said we square the bottom one, x raised to the power of 3 minus 3x plus 6. We square this. So that is how we go about this. Now we come to this one. That one will simply what I've shown you, that one is the same as 2x minus 5 raised to the power of 2. You drop the exponents, there will be 1 over 2 into 2x minus multiply this by 1 over 2 into 2x minus 5. You minus 1, there will be negative 1 over 2. You also multiply again, do not forget, also multiply again by the derivative of the inside. Also multiply that by what will be by 2. So this is what is go about, because yeah, this is what we're supposed to do there. That is what you're supposed to see. Let's say we have y again. If we are given this y raised to the power is equals to cot raised to the power of 4 square root. Here we have tan 3x and then squared like this. So if we want to differentiate this, this will simply equals to what? Drop the exponents, will be 4 cot, you subtract 1, there will be 3 into square root tan 3x raised to the power of 2. All right, now we come again, we multiply by the derivative of cot. Derivative of cot will be negative cosecant squared. You write whatever it is here, the angle as it is there, square root of what? Tan 3x raised to the power of 2, like that, like this, right, like this. So we are not done. We're supposed to multiply. We are not done. We are not done. You multiply again all of these by the derivative. We did differentiate that. We multiply now by the derivative of the inside. Now the inside will be, remember now we have a square root like that. So that, guys, now will be a power rule. Remember, the square root is simply how to remove the square root. This will simply equals to tan 3x raised to the power of 2 into 1 over 2. So you're supposed to drop the exponents, will be 1 over 2. Tan, again we'll have tan 3x squared. Subtract 1 will be minus 1 over 2. See, then you multiply by the derivative of the inside again. Multiply by what you have there. Then if you multiply again by the derivative of this, derivative of what now? Of tan. Derivative of tan by itself, tan is simply secant squared, will be secant squared. There will be, let me write it here for the sake of space. Let me write it here below. We know that supposed to multiply by, or let me just show it here, but we know we're supposed to multiply again, multiply whole of that by the derivative of tan. We know it is sec squared. What is the angle there? Will be 3x squared, right? multiply again by this angle again, by the derivative of that, right? Multiply again. You see it goes, you come here, you come the inside, come there, you come that, come there, you multiply by that, will be what? Drop the exponents, will be 6. 2 multiplied by 3, 6. 6x will be 6x. Then that is how you go about differentiating this thing, guys. This is how you apply your chain rule. This is how you apply your chain rule. This is how you apply the chain rule. So by the way, thank you guys for watching. I think I will end here. Thank you for watching. And then if it is your first time watching my video, may you kindly subscribe to my YouTube channel and click the notification bell so that you'll be notified whenever I post the new video, because I'll be posting some typical question and exam previous question papers. Then we'll look at we'll see how we dealing with logarithm differential. We'll see inverse function, trigonometric inverse function, differential, the one that for example it's when we're talking about things like this, when you're supposed to find the x of maybe sine minus 1, like this, things like this. Those are inverse. Things like dy, let's say we are given things like this, yeah, things like that. Things like you see the inverse arc, talking about arc is just the inverse, yeah, things like that. We'll see how we find the inverse. There's the inverse of tan again. See how we differentiate the inverse of cos, which is the same, this thing is the same as arc cos x. This is the same as arc. Arc means the inverse, tan x. We'll see those things, cosec. We'll see when we're dealing with the inverse of cosec x, whereby this is the same as arc cosec x. So we'll be dealing and then solving. There are many we'll look at all of them. Cosec, we know we have those, sine, all of that. Just subscribe there, then we shall do them step by step. All the best. Thank you for watching.